Hello and welcome to Patchmouth, where today we are going to patch your math knowledge on the structure to proofs in geometry. Alright, today we're focusing on the structure of the proofs only, not the specifics of the proof. We will fill in as many specifics as would be required on a day one geometry course, which is not a formal proof, so don't worry. We're going to be focused on what is given, what we're being asked to show, and then me and my audience are going to bridge the gap between the given and the show with some sort of math fact. That's a definition, theorem, postulate, or property in mathematics that will bridge the gap between the given and the show. Let's get to it. So in this problem, it says ray BD splits angle ABC into two angles, and the measure of angle ABD is 42 degrees, and the measure of angle DBC is 31 degrees. Then find the measure, or they gave it to you. Then the measure of angle ABC is 73 degrees. Our goal is to prove that the measure of angle ABC is 73 degrees. To prove that based off from what is given to us. So if we look, our given, we are being provided what's called an if-then statement in mathematics. Here is our if, here is our then. These are the easiest to pull your given and your show from. What is given is ray, we know that, ray BD splits angle ABC in two. All right. All right, so we have been given that ray BD splits ABC into two angles, and I wanted to go ahead and halt there because we were given more, but think about what this says about ABC. We have a ray that's splitting in two, so what do we know about the two angles that make ABC up? Well, it means they share a common side and a common vertex, meaning they are adjacent angles. So you'll see here I have the adjacent some information about what adjacent angles are. You'll see there it's two back-to-back angles sharing that common side with that common vertex. Now, they use different variables in this example, but please don't worry. Just wanted you to realize that's what this part of our given relates to. Now, knowing that also, we were also given a little bit more information, and that is the measure of our two angles that make up ABC. All right. So then we also have these are the angle measures for those two internal angles. Well, then we're going to ask ourselves, what are we trying to show here? In an if-then statement, lucky for us, our show is always going to be after the then. All right, it's always going to be after the then. Looking here, you'll see that we're trying to show that the measure of angle, that external angle, that measure of angle ABC is 73 degrees. Now, at no point up here can we assume our show is super important. At no point up here can we assume our show. We must prove this to be true based off from what is given and the math fact that bridges the gap. All right, so we already talked about the fact that since we have a ray splitting up one angle, we have adjacent angles, two angles formed on the inside of that angle. But we've also been given the measure of those two angles here. And we need a little bit more information about two adjacent angles and the exterior angle of those adjacent angles. If you have your geometry definitions, theorems, postulates, and properties bank, you're going to go down to the postulate section and you're going to see a postulate that says, and sorry, this infographic is blurry. I pulled it off from a resource and it didn't come out right. You'll see that it says that the angle addition postulate here, look at that image. We've got two adjacent angles there. All right, two adjacent angles. And an exterior angle. It says if we have a point on the interior of ABC, then we have that ray that was discussed. Then we get the adjacent angles. Then we know that the measure of angle in this scenario, AOB, plus the measure of angle, OBC, equals the external angle, ABC. So we come over here, and the idea that bridges that gap is the angle addition postulate. So since ray BD splits our external angle in two angles, those angles are adjacent. Because the measure of one of our internal angles is 42 degrees, and the measure of one of our other angles, our other internal angle, is 31 degrees. 31 degrees, we know, all right, we know, based on the angle addition postulate, that we know that the measure of angle ABD plus the measure, and we're going to write it with the variables from this problem. All right, notice your postulates will have like sample variables and things written in them. You'll use the variables in the given problem. D, B, C equals measure of angle A, B, C. Technically, we need to put a therefore here if we're going to be. Therefore, we know, based on the angle addition postulate, that the measure of angle ABD plus the measure of angle DBC is going to equal the measure of angle ABC. So, since we know that the measure of angle ABD is 42, we're going to be using substitution here. We're just going to substitute that measure in. This is being substituted in for that. All right, 42 degrees. And then the measure of angle DBC is going to be substituted as well, 31 degrees. We know that 42 degrees plus 31 degrees equals 73 degrees. Therefore, all right, that's just a therefore symbol, dot, dot, dot. We proved that the measure of angle ABC is 73 degrees based on the angle addition postulate. And we are done. So what's super important here is that you're able to just outline what you're given, what your show is, and then name the math fact that bridges it. If you can do the work with that math fact that helps bridge the gap completely, that would be great. But for the student I'm creating this today, they're being asked to just do the structure, and maybe if you can take it a little bit further, as close as you can get to that formal proof as possible would be great. But on day one of geometry, something like this, maybe even a little lighter, as long as you got this key idea here that bridged that gap with the angle addition postulate, you are good to go. All right. Thank you so much for your time. Your math knowledge has just been patched on, bridging the gap between your given and your show in geometry. I hope you have a wonderful rest of your day.